Is it on? Hey, how you doing? I suddenly thought, maybe the mic receiver pack isn't on. It's on. Hello, welcome to the show. It's me, John Park, and this is John Park's Workshop. You know, all of its glory. It's a mess, I know, but it's my mess, and I invite you to please join me right now into my mess, into my workshop, to play around with some stuff today. Thanks for hopping over into the chats. We've got people over on our YouTube chat. Hello to Johnny Bergdahl and Dave Odessa. Thanks for popping in there. If you're somewhere else and you're wondering, hey, where is the chat? Then I encourage you to check out the Discord, which is that right there. You can get there by going to adafruit.it/Discord, and then once you join our server, look for the live broadcast chat channel. It's that one right there, very slightly highlighted. We have lots of other channels, so you can go check things out, but during the show, this is a good time to check out the live broadcast chat channel. Hello, Toddbot, who just joined us. Hello, Squid.jpg, Thin Man, Blitz City DIY, Paul Cutler, Johnny Bergdahl, Jim Hendrickson, C. Grover. Hi, hello, howdy. What have we got? So I have I think a fairly packed show for you today. I've got a coupon code so you can save some money at the Adafruit shop. I have a recap of the product pick of the week from Tuesday. I've got a CircuitPython Parsec, which will give us a little bit of a preview of an upcoming project after the current project. I've got the sort of kickoff, sort of continuation of the Larsio Paint thing last week. This is Larsio Paint music that we'll be looking at on the Fruit Jam. Also works on Metro RP2350, so I know the Fruit Jam is pre-release, but you can play along with pretty much all of the things that I'm doing and other people are doing on Fruit Jam with a Metro RP2350. Will do pretty much all that stuff. What else? I feel like there was something else. I teased a little thing yesterday. Talk about that and look at some 3D modeling stuff regarding that. I'm excited about that project. So let's get on with it. First of all, if you want to head over to the Adafruit shop, which is at adafruit.com, and you want to save some money buying some stuff, this is your coupon code for the day. You're going to get 10% off on anything that you buy that we can physically stick into a package and send to you. So no software gift certificate subscriptions, but physical things, sure. In fact, let's take a look. If you head on over to Adafruit, main page shows some new stuff. Hey, maybe you want to get one of these wild-looking Pomeroni inky frames for about $11.495 less. Then the coupon code Space War will do it for you. That's right, the coupon code is Space War. And that main page there has a little link next to that first banner called View All New Products. I encourage you to check that out. That'll let you know what's in stock. There's a whole bunch of neat Pomerone stuff that came out. There's also this Raspberry Pi Power over Ethernet Plus injector. Pretty cool. You could get one of those and save some money. We have some new feathers. There's this ESP32 S3 reverse TFT with the WFL antenna, so you can click on a little antenna and upgrade your signal strength on a feather project. Some new snap-on enclosures, and the list goes on and on. So check out all these neat, fancy things in the new products section, or head over just to products and check out some categories. One that I like to do actually is go to search. So if I just search right here and type in Adafruit and click off the out of stock and click on the most recent, this is mostly, some things sneak in like this wired mouse that doesn't really have a manufacturer of note, but this is mostly new Adafruit stuff. So things that Lamore has cooked up and built, you want to know what you could get right now. You want to know what's the latest. That's my trick right there. Search for the word Adafruit, because in fact our boards usually say Adafruit Metro, Adafruit Feather, Adafruit Trinky, etc. Most recent, in stock. Throw some neat things in your cart there. I use that trick when I'm looking for product picks, for things to do on the product pick show, because I want them to be things that are in stock and recent if possible. So that's my little tip for you there. Also, sorry, I'm just going to goose the volume level on my mic input. Why is it hanging around so low? That's weird. I bet it's going to jump. Oh, there we go. Okay, now we're a little hot. And, okay, that's good. I'll try not to shout, but I wanted to pop that up a little bit. I'll also be playing around with the mic a little bit later when I show you a music demo with the Larsio Paint music. So there will be some fiddling there with mic levels. All right, so yeah, that's the coupon code. If you want to go and buy some stuff, throw it in your cart. That coupon code is good until midnight tonight, East Coast time. Mic's a little hot. And Space War. Why? We'll talk about that. Okay, next up, I've got a show on Tuesdays, which is the product pick of the week. And on it, I like to pick something. I like to show it to you. I like to give you a big, huge discount. With the help of the new products team, we give you 50% off generally when possible, when it's, especially when it's an Adafruit product, because we can afford the margins versus third-party stuff. And here is a little recap from this week. It is the Metro RP2350. I have the flex connector going to the HSTX connector and then to the little breakout for HDMI-shaped DVI video. And you can see I've also got a USB keyboard plugged into USB host there on the board. So all those things are happening inside of CircuitPython. If we take a look on screen, it says, "Welcome to Metro RP2350. And then if I type on the screen, I'm just going to show words up here. So I'll retype that. Welcome to the RP, oh, not RP, Metro RP2350. Hey, now it's a disco. Metro RP2350 no PS RAM edition. Indeed, that's what it was. By the way, I don't know if I made mention, but you can add PS RAM to that one. So if you go back over to Adafruit PS RAM, we probably have a link actually in the Metro. This right here, generic 64 megabit serial pseudo SRAM. I believe that one will work on there. I believe that'll work on there. You can see I bought one recently, but I haven't tried it yet. Is that the same one that we were putting on the bottom side of the M0s? The M0 Cutie Pies? Might have been. All right. Enough misinformation. What do we have next? Hey, look. Hey, for the CircuitPython Parsec today, I want to talk about reading data from USB gamepads inside of CircuitPython. Here what I have is one of our Feather RP2040 USB host feathers. So you can see it's got two USB ports on it. One is USB-C for giving it either just power or data when you're programming it or putting assets on it. And then it has a USB-A port to host things like mice and keyboards, and in this case, a gamepad. So this is sort of a generic gamepad from Amazon. I think two of them for $14 or something like that. Doesn't even really have a brand name. It's the model GP100. This is one that I was using with the Pico 8 project. So generic gamepad, but pretty much any USB gamepad. If we want to get some data off of it, if we want to find out what buttons are being pressed, we can do that right here in CircuitPython. So if you take a look at my REPL here, I'm just going to restart this, and you'll see the first thing that happens is we're scanning the USB host port, and we see a product ID, vendor ID, manufacturer name. They didn't fill that out. What's the product? It's a USB gamepad, and then the interfaces that it's coming in over. So this is set as a USB gamepad. And then we have the data stream, the message that's coming from it when something changes. So initially we just get one, and then it's waiting, in this case, for something to change. So if I press, let's say, down button, up button, down button, you can kind of watch. There's actually some repetitions of the data here, some redundant stuff. But if you watch the first and second line of the code there, it's 7F00 or 7F. So as I press those buttons, we're getting different buttons that are being pressed. So this is pretty useful on its own just to see if things are working. And the way this code works, this is actually in, I'm going to show you in a minute, the Learn guide that has code from Foamy Guy on detecting USB gamepads and reading their data specifically. The way this works is it's using USB core and the Adafruit USB host descriptors library. Now, I won't go into the bulk of the code because it's mostly just asking for the message that comes from a device that's been found and then printing that. However, I will show you a more advanced example of taking that and using it to name the buttons so that we can reuse them in the code. So if we take a look at the game configurator.py, and I'll post this in my Learn guide or my Parsec repo and paste this into here. This is going to either try to load up an existing map. I already created a little map file for myself called snesbuttonmap.py. If it doesn't find that, it'll set about having you create that by configuring it. But this one's already configured, so now you can see instead of just that stream of data, I'm getting any buttons being pressed by name. So A, B, Y, X, all showing up at once there or individually, left, right, up, down, start, select, right shoulder, left shoulder. All this is a mapping of that message that we got before and then giving it some nice names to use. You can then, of course, use this as a launching point to actually do things inside of your code, play a game, move LEDs around, change colors, so on. Once you do that, you've got yourself a really nice, neat, inexpensive, nice form factor set of a whole bunch of buttons, and this can be extended to other types of game controllers as well. If we take a quick look over in Learn here, and I'm just going to do USB host, let's see, oh, where is it? I think it's actually on the Learn guide for the Featherwing here, isn't it? Oh no. Is it this one? No, this was an Arduino one that Liz did. All right, let's look up Foamy Guy. Maybe we'll find it that way. Sorry, I thought I had bookmarked this and didn't. Foamy Guy, USB. It's okay, I have a secret weapon. I'm going to grab the link from where I saved it a second ago. Hold on one second. This will be under Learn. in a yet unpublished guide. Is that where I put it? USB read data. All right, I'll come back to you with that. I don't want to torture you by having you wait. Maybe we'll come back to that in a second. So let's go back to looking at the code here, though. There it is. So this is the configuration file. So this is the message and the bit that gets set for each of those different combinations after we've sort of scraped that data by learning by example. And then back inside of here, we can use those to just print out a nice, neat name. All right, and so that is how you can use the USB core and USB host descriptors with a host feather and a USB game controller to read your gamepad button presses. And that is your CircuitPython Parsec. All right, where did I put it? Where is that code? Let's continue the search. Hold on, bring this back up. I don't think it is here. Oh, I wonder if it was just in the... I wonder if it was something I found looking at the product page. Sometimes we have a set of learn down below. No, primary guide. All right, let's try see all guides. If anyone else finds it first. Oh, maybe it's under CircuitPython X. Yeah, it is. Okay, it is in the Learn guide, main guide. USB, it was not a separate guide, it was this page. USB host read data and USB host device info, which I've gone over before. So here, phew. All right, so this is the page by Liz, the code by Tim. That was why I was having a hard time finding it. And here is the sort of fundamental example you want to grab if you want to print out the messages that are coming from your game controller that's plugged in over USB host. Once you have that, once you have those messages, you can start to remap those to other things. Shoo! All right, I knew I wasn't going mad. Okay, so I can put that away. One of the reasons that I wanted to do that and get that example up and running was not actually for a gamepad, but for a Guitar Hero controller. So there are some interesting projects using Pico microcontroller, RP2040, with the PIOs as USB host, which is what we're doing on this one. This doesn't have the separate chip. It's just using some PIOs to do USB host. That's actually working really well in some of the plastic guitar playing game community for things like Clone Hero and now Fortnite Festival, which is another one by Harmonix in the vein of Guitar Hero. And so I wanted to see if we can use a USB guitar, such as the, do I have it here? No. Such as the Explorer that was made originally for the Xbox 360 and it has a USB cord. It's not a wireless one. Plug it into this host and then be able to use that for anything like bridging it to applications on a Mac or a PC that weren't compatible with that controller, or just using it for any of your microcontroller projects. Once you're hosting it, you can read a whole ton of data coming off of the instrument. Okay, so now next up, let's jump into this thing actually. Wait, let me check my notes. I feel like there's something I'm forgetting. No? Good? Okay, good. Yeah, so let's take a look at this thing. This is this 3D printed arcade cabinet miniature that I made. This is based on the incredible cabinet design of the very first arcade game called not Space War. Space War was on a PDP-1 at MIT, but the inspiration, that was the inspiration for Computer Space. So this was something that Nolan Bushnell, before Atari, but as Syzygy, put together, got nutting and Associates, Nutting Associates, to manufacture. There were 2,300 of these cabinets made, full size. They stand about that high. Fiberglass with sparkle paint on it. So I used some, I don't know if you can see it too well, I used some, there we go, some sparkle filament in this print here. And it is sort of a precursor to asteroids in a lot of ways. It's a ship floating in space. You have a thruster, you have rotation, and you can fire missiles at a couple of UFOs. So asteroids later added a whole bunch of rocks as well as the hyperspace. But very similar. It was popular. They sold through all 2,300 of them. It wasn't popular enough to make another run of them, so that's it. It's limited. And so getting your hands on one is a little expensive and difficult. If we take a look at just some images of it, you can see this is this gorgeous cabinet. It was made in red, yellow, and blue, and then there was a two-player version made in green. There was seems like a prototype that was made in white that was at CES or the equivalent when this was first shown off, and then it also appeared in Logan's Run, I think, in the background of a apartment scene. But this is the computer space cabinet. Here you can see this is what the game looks like, a little star field, and this is actually a really nice website with a history of the game. Here you can see a video of the game in action there. Played on a 12-inch black and white GE television, so it was not even anything fancier like an RGB monitor, which, you know, those came much later. It was a simple black and white image, and I think it was tapped in directly. It didn't go through RF or anything. The signal went directly to the tube. There's Nolan. So this game, I kind of got interested in its history a bit and the cabinet design in particular. And I saw some items over the recent past about 3D printed computer space cabinet. So I believe a British or maybe UK arcade enthusiast built this one you see here from 3D printed parts. So they scanned an existing cabinet and then printed it in small sections until they had a full buildup of the cabinet. There it is, 3D printed full-size cabinet, and amazing. And you can download this mesh. In fact, I'll show it to you. The scan is a bazillion triangulated polygons, so high resolution, great to just take it and print it as is, but pretty difficult to do any editing on it. So I decided I wanted to build one from scratch using more minimal geometry so that I could then modify it if I needed to be able to try to fit a little OLED in there and an emulation of some kind of the game. The game is actually done in TTL logic, so there isn't code to emulate, but people have made some emulations of it anyway. I know someone reproduced it on FPGA, and there's a version of it running on the internet that's on the PDP-1 in a PDP-1 emulator. So this is a 3D print of the one I made. This is a 3D print I had done previously of the scanned version of it. So I happened to go bigger. Maybe I can make them look the same size. So mine is pretty similar. It's not exact, just because I haven't spent an endless amount of time tweaking it. But I wanted to show you what that model looks like and talk a little bit about my plans for it. This is a version of mine before I made it asymmetrical. So one of the odd features of this thing is the asymmetrical design. Let me see if one of these images shows it off. Yeah, you can see it in this one here. I'm not going to get that thumbnail image back, am I? Yeah, you can see it there. The player console is off to the side. I don't know why. Maybe it makes it a little easier for someone to watch, or just because it looked cool. But I modeled it almost entirely just to get my geometry layout symmetrically, which means I can mirror it down the center axis and only have to deal with one half of it, and the changes are applied to both sides. And then eventually I, as one of my later steps, went and and made it asymmetrical like that, as you can see. So let's take a little look at what this looks like inside of Rhino. And one of the reasons for the project was that usually I use Rhino for CAD stuff, mechanical designs, things that can be created with NURBS surfaces derived from curves, and procedural models using Grasshopper. This is much more like what I used to do in my computer animation days at Disney and other places, is polygon-based modeling with limit surfaces using subdivision surfaces. So that's all I have to deal with as far as the number of vertices and edges and faces is a very low resolution thing. And then there's an algorithm, subdivision surface algorithm, that derives this limit surface from it, which is what we can then create a mesh from for 3D printing, again, a high-res mesh. If you look at this is the one I downloaded. So it's dense, right? So this was made with a scan. I didn't look actually, but it's probably a handheld scanner, I'm guessing, that you walk around with and collect data. So it's incredibly accurate, which is great, and makes total sense for printing the large cabinet that they printed. And I'm sure it still requires a lot of post-processing and gluing and sanding and screwing it together and stuff. But while I'm able to 3D print that, it's not straightforward to do things like adjust things, make tweaks to it, add space for a microcontroller, mount an OLED in there. So that's why I went about wanting to create my own 3D model of it. And I wanted, since I haven't used these subdivision surface and polygon style tools inside of Rhino, I used to do that stuff much more in Maya, I decided this would be a good project to learn those tools on. These types of surfaces that have sort of multiple holes in them and tricky connections between sort of offshoot parts, those are tricky to do with NURBS. You end up with some pretty tortured geometry to make those types of surfaces work. Much better type of thing to do in subdivision surfaces, which is why I went about that. So just a little about subdivision surfaces. A couple of things that are neat about these is, like I said, they have this relationship between, that's the actual geometry, that's the sort of final averaged surface, the limit surface. We can manipulate it, you can see, with just these very few points, unlike that scan, which is if you grab one point, you're grabbing one of 100,000 that are sitting in that area, and it's just going to make little zits and things if you pull them. This instead, if I go and make a change to just that one vertex, I get this nice soft fall off of the averaging of the four vertices that impact that set of surfaces there. You can pack in geometry where you need hard edges, but one of the nice tricks about a sub-D surface is a Catmull ROM sub-D surface is that you can specify creases. And it's a simple designation with this sort of universal style sub-D surface that you can say, okay, if I pick an edge, let's pick this one in the front here. I'm going to pick an edge loop, so a series of, I've got like eight edges there that all kind of constitute this front shape. So I can go move them, right, and change that a little bit. I can also crease that, so I'm just going to run a crease command on it, and now we get a very hard edge. I'm going to hide those control points. So now we can get this really neat shape that's not accurate to this cabinet, but I will need some hard edges on the inside where some parts are going to go. And there are some of those, I think, in the real one where control surfaces are placed. You can do it without adding 3, 4, 5 edges and packing them in tight. That's also a legitimate way to do things. But in this case, I can get a lot of control just from creasing a surface. And those can be uncreased. I don't just have to undo. I can go and pick those and say, never mind. Let's go back to the normal averaging that we have. So that's sub-D surface in a nutshell. I did one of the nice things about looking at this sort of surface in in modern, fairly high resolution lighting models is that you can evaluate the continuity of surfaces and look for ripples and nice smooth shapes just with sort of a plastic shader. So if I turn off the control points on here and let's switch over to a rendered mode, I've got a pretty nice shiny plastic shader on there that I can use to look for these sort of specular light reflections in there. Help me look for like this. I don't think I should be seeing right here. Oh, I don't think you can see my cursor, can you? Sorry about that. In the mode I'm showing, I don't think it shows cursors. Hopefully you've been able to see most of what I've been showing. But I can look for a little discontinuities and, you know, should that be flat or slightly curved there, and so on. So real happy with that. The sub-D tools. This is actually Rhino 7, and there is a Rhino 8 that I haven't upgraded to yet. I should mention, this is kind of the primary mode of modeling inside a Blender. So again, I don't like to recommend you go out and buy an expensive pro-grade tool like Rhino if you don't need it. Usually the stuff I do showing things that are CAD-like using Rhino and Grasshopper, you could use Fusion 360 for. This type of modeling, this type of polygon subdivision surface modeling is the bread and butter of programs like Blender, which is free and open source, or Maya, 3D Studio, the list goes on, Cinema 4D. Most of the entertainment apps that are designed for making stuff for film, animation, VFX, games, they work more in this polygon sub-D surface mode. So that is it. That's what I've got. I'm not sure yet. I'll be trying out a couple of different displays that I have in there and looking into what kind of either a little demo loop or a playable game I can put on this guy right here. It prints pretty nicely. Let me go to a full view again. It prints pretty nicely in this orientation. I get some little flat marks there. I have not tried ironing mode. There's an ironing step you can add to your G-code in the slicer I'm using, Bamboo Labs, that will essentially use the hot nozzle without any filament to smooth layers as it goes. Could be an interesting use for that. And then there's one little spot right at the top there, unfortunately. So maybe, you know, I don't want an ugly top on it. If I print it in this orientation, the top is not flat. It's a little slight curve, and that's where you tend to get these artifacts here. Could, of course, make it and sand it and Bondo it and paint it and gloss coat it. I really don't feel like doing all of that, so I'm hoping to just put up with something like that. But I don't know. Maybe I should paint it. We'll see. So that's the little preview of the computer space thing. And I actually want to use that to segue into a Kickstarter segment. So Phil mentioned last night he doesn't like to show a Kickstarter unless he's personally supporting it. Lamore personally supporting it. I'm personally supporting this one, and this one is a arcade game relevant one. In fact, one of the only times I've seen computer space was a 2-player computer space green cabinet that was at this Pong exhibit run by Van Burnham. Van is a video game historian, and she's the author of this book, this gorgeous coffee table book, hardcover, called Supercade, A Visual History of the Video Game Age, 1971 to 1984. This came out originally in, I want to say, like 2004, 2007. She is doing a revised, revitalized, up-resed, remixed edition, and this is a Kickstarter. I backed it to get a book. You can back it at different levels. I'll throw a link later in the over in the chats, but this is a pretty cool little video that gives you an idea about it that I'll show. I don't have a download of it, so I'll just show this playing over here on Vimeo. play. So cool looking project, and I selfishly want some of the bonus tiers to be met. So I'm hoping more people will back it. They've met the goals, but there's 4 days to go, and there's a game called Scramble that has the most gorgeous marquee art of any video game, in my opinion. I love it. There's Van is designing I think a gatefold for one of the bonus. I think the next bonus level, whatever you call that, tier stretch goal, is going to be to add like a gatefold poster about Scramble, which is pretty great. So that's entirely selfish, but I think it's a cool looking project, and go read up about it. I'll throw a link later. Very cool history of video games, gorgeous photos, gorgeous art. Check it out. So that's that. Maybe computer space will be in there. I think it is. So it should be. It's the first. All right. Now on to the current project. So we'll jump over to the workbench here. This is Larsio Paint music. So last week I showed the Mario Paint music running on an old SNES. And so I've started to create a simple version of just the music program running on Fruit Jam. Let me just open my Discord so I can keep an eye on things. And actually, I'm going to go turn up the mic that I have on that little powered speaker, and just let me know if there are any audio issues, if you end up getting an echo or two of me, or me out of phase in one ear, or if it all works great. Just let me know once I start playing music. So I've got the Fruit Jam, which is powered over USB-C by this Mac laptop that's over here. And for this iteration of it, for this simple iteration of it, I was mostly just wanting to work on the UI of this 4 bars of music. You can place eighth notes, you can place them on a scale, you can clear notes, erase notes, loop, playback, play. And when it plays right now in this version, all I'm doing is sending MIDI data back up to that laptop. The laptop is running Ableton, but any software synthesizer that can bring in MIDI would be playing notes. So that's the setup right now. Goal is to remove that need. We could still keep MIDI, but have sound coming directly over the Fruit Jam's output DAC using Synth.io and or a mix of sampled sounds. So those could be MP3s or waves. So that's the goal. If you remember from last week with the Super Nintendo Mario Paint music, we had sort of a mix of, I don't know if it was all samples or some synthesis, like the little Game Boy is a PWM sound that just is probably just a synthesized sound on one of the SNES sound chips. I don't know much about actually how the SNES sound works, but some of them are samples, clearly, and I think it played, yeah, you could store samples on the cartridge, so it plays back some of those little Yoshi noises and some other clearly sample ones. Some of the drum sounds might be samples. So that's the goal. I'll play right now. This is just playing through some synthesizer voice or a sampled voice. I think it's a synthesizer voice I have running on it right now. Palm guitar. I don't even know if that one's sampled or what. I don't know Ableton well. Let me hit play. You'll hear it play through these notes and it'll just loop. And then it's just going to loop again. So you'll see a little red play head moving along there. And you can see I've got polyphony going on. So let me clear that there. And I'll take a moment to ask if anyone in the chat can let me know if that is audible, if it's drowning me out. In fact, let me just, I'm going to throw down some random notes. I'm going to play and I'm going to watch my audio meters over there to see if it, yeah, you should be able to hear that. Yeah, okay. So I'll clear that out, but I'll just wait a moment. Yeah, thanks. Toddbot says, yep, can hear it. Sounds good. So the interface as of right now, so this is all running in CircuitPython. You can see I've got mouse support. So this was the impetus behind this. Larsio Paint for Super Nintendo came with a little rollerball mouse, a 2-button rollerball mouse. It does not ever seem to use the second button in Larsio Paint. And we have USB host on the Fruit Jam as well as the Metro RP2350 if you plug in the external dongle. So I've got a mouse plugged in here, and I have a 320 by 240 screen space that the mouse is being mapped to. You can see here I've got a little sort of not so accurate illustration of the staff. The proportions are a little funny, and some bar lines for the in and out of it. But these, as you can see, as I move the cursor around, which is, I'm going to zoom in just a little bit there, bring this into frame. You can see I have a little crosshair cursor, and then which I can move freely, but then I've got notes which snap to their viable positions. So I'm using this as 8th notes, so 1, 2, 3, 4, 5, 6, 7, 8 positions in one bar that it can snap to. And we can snap vertically either to lines or spaces on this staff. I'm also printing out the position of the note, so if I want to lay down a C, oh, hello. I don't know why that first one doesn't want to go. I may just have a bug. So we can't place that on the very first position as a C. As I right-click, I can delete notes. Is it going to draw this one? There it is. There's the C. So here's a C, E, G. This should be a nice little chord. Very nice. Oh, I just cleared it. So I can place quarter notes here like this. These are off by 1 on that second measure. Clear that. And as you heard before, we've got polyphony. I actually don't have any real limits on this right now, so you can play a big, fat, hairy chord here. Whole bunch of notes. And then I've got a loop. Right now I'm just looping after the 4 bars. I may add an ability to set the loop point where you want. And one of the features of the Larsio Paint music was that it's actually got, I think, 24 bars, and it scrolls. I don't know that scrolling is going to be too realistic just in CircuitPython, so I may just limit it to this or do some pages of some kind to write more than just a little repeating loop. But you can see here we can quickly sketch out some little chords and some little kind of counterpoints to them. I'll put a little throbbing bass down below. And what I found, and what you're probably sensing, is that, boy, it would be nice to do some things like move notes around, group select. These are none of the things that Larsio Paint had, but we may be able to add them here. This was kind of the limit to the controls. You could put 3 notes, 3-note polyphony in the Larsio Paint music. There was no right mouse to delete, so if I want to get rid of a note, I couldn't just go and then place a new one. I had to come down to an erase button and use the eraser, which is unfortunate. Let's play this. Another thing that I added is the ability to add notes while it's playing, which is much nicer for iteration. So if I want to come in here, This being MIDI, we can change the sound a ton, so I'll just sort of pick a random sample to play instead. Kind of a little echoey piano kind of sound. And we can just hit stop down here. So I'm going to work on the graphics, make them cuter, and then I'm really, since I've named it Larsio Paint, I am interested to see, can I get a little sprite of Lars, because we had the sprite of Mario running around on the staff to let you know, instead of my little red playback line there, they have Mario running across the top as the and jumping as the staff is scrolling by, as the music's scrolling by. What else about it? So yeah, so that's where the project stands right now. Let me know if you have ideas on features that would be nice to add. It should be something that you can, I'll of course put up a learn guide in the code. I try not to get too carried away with it, so that it's sort of a framework and you could make it your own. I will make some nicer graphics for some of this, maybe use some bitmaps for these things down here instead of just shape, display.io shape things that it is currently. Maybe ability, depending on how samples and stuff go, ability to change keys or transpose. But again, that's probably good, better left to the user for how they want it to work. But yeah, I'm really excited about this running in CircuitPython. The timing seems to be pretty good and tight. It's simple what it's doing right now as far as sending MIDI. I have no promises that it's going to survive the switch over to samples, maybe Synth.io, because it's pretty efficient. We'll see what the frame rates and things are like. I may reduce what's moving and changing on the screen. And Lamore said overclocking may be my friend, so I'll have to look into that. I don't know how overclocking on the RP2350 works. It may be similar to what I had done on the RP2040, was just setting a different clock frequency. And I hope it doesn't overheat. So that's Larsio Paint music. And Paul Cutler says in the chat, the Fruit Jam is never going to stay in stock when it comes out, I have a feeling. It's pretty cool, I'll tell you, because, you know, having USB host and HDMI or DVI video out built right onto it, as well as an audio output, is pretty compelling for these kind of little mini baby computer kinds of projects. Stuff I'm not using right now that I could and may. We've got NeoPixels built on there. It might be fun to use those for something, maybe tap out the metronome or something like that. We've got onboard buttons on there, so if you want maybe some of this to be on screen but play and pause or something, is little transport controls right on the button there. Could be kind of nice. And then there's a STEMMA QT port on here and some JST connectors for analog stuff, so you could add a whole bunch of other add-ons to it if you want. But that's that, yeah. So let me turn that mic down there, and we can wrap things up because I gotta get working on some of these things. Let's turn that down there. Let's see. Oh, sorry, I was not checking the YouTube chat during that section, but hello, Paul Longley says, first time watching, very cool, thanks, hello. Hi, VJ Pussycat, good to see you. And could use a channel selector, Charles Burniford says. So tell me, channel selector. Are you thinking MIDI channels? That would be useful, yeah, if this is going to stay a MIDI thing. The Mario Paint, sorry, I'm not on screen at all. The Mario Paint paradigm is interesting because you essentially can pick samples. I think there's 12 or 16. So when you pick the mushroom, you're really picking from a sample set of drums. And I think it might be just pitched, repitched, not different samples. But yeah, on MIDI, it'd be kind of nice to say, okay, pick a mushroom note and that's going to play over MIDI channel 2. Pick a Game Boy shaped note and that's MIDI channel 3, and a goose shaped note and that's MIDI channel 4. And then you can send out to different sounds and be much closer to the Mario Paint music. A great idea, Charles. Thanks for that. I love that. So yeah, we'll see. We'll see where this goes. Thank you for coming and checking this out with me. I'll mention again, if you want to go and pick up some stuff, can't get a Fruit Jam yet, but like I said, RP2350, and the HSTX connector and a MIDI host. Look, I got one right here. Got a keyboard plugged into it. That right there, that'll do everything I just did. Metro RP2350, not the PS RAM. No PS RAM, you don't need it for this. HSTX DVI output and the little flex cable, and one of these little USB breakout dongles for USB-A soldered onto there, and that is doing everything that's... In fact, I could probably, pretty sure, just copy and paste that code onto that and it would work. There's nothing specific to the Fruit Jam. I think even the pinouts on the HSTX I think are the same. So that should just work. You get that or you get it, who knows what. But whatever it is, don't pay full price. Don't do that. Save 10% with that coupon code right there today. Space War. That's going to get you 10% off in the store. So do it. All right. Hey, thanks again, everyone, for stopping by. Thank you to David Dessa, Johnny Bergdahl, Ortega Computacion, Paul Longley, VJ Pussycat, Charles Burnham Ford over in our YouTube chat, and the whole gang that you can see right here over in our Discord. I think these are the people that have been here the whole time. And hi, Paul, you weren't here at the beginning, so I'll say hi to you. Thanks for stopping by. C. Grover with some ideas, possible features, chord, auto harmony, percussion, arpeggios. My goodness. Let's build a DAW in the Fruit Jam. You know I'm dying to get it out onto a CRT, of course. That'll be some other challenge. Okay, hey, thanks everyone so much for stopping by. That's your coupon code. That's me. It's Lars back there. You can't see him today somewhere. And that was John Park's workshop. So I believe Scott is going to be doing a deep dive tomorrow. Come check that out. He's back off of vacation. And then we'll be back next week with all kinds of cool stuff. There'll probably be a Desk of Lady Ada sometime over the weekend. And then on Tuesday, I'll have Product Pick of the Week. On Wednesday, 3D Hangouts, Show and Tell, Ask an Engineer. Come on by. Thanks, everyone. For Adafruit Industries, I'm John Park. This has been John Park's Workshop. Goodbye.